Hi everyone. Today we will re-explain the notation and the concept of scientific notation. Okay, so what we mean by scientific notation as a review from the grade 9 materials. A scientific notation, it is a way to write any number, any big number or small, very small number as a multiplication of a, a non-zero one-digit number. We mean a number between one-digit number between 1 and 10 and with the power of 10. What we mean by the power of 10? So we mean 10 power n, where n can be positive or negative. So a number is written in scientific notation if it is expressed as the product of a number between 1 and 10 and a power of 10. So how can you write a given number in scientific notation? First of all, at the first step, we move the decimal point, okay? So that it is positioned between the first and second digit of the number. So if we have a any number, big, very big number, or a very small number with decimal point, so we move the decimal point and position it between the first and the second digit of the number. We mean the first and the second figure, a significant figure. Then we count the number of places back to the original position of the decimal point. Why? Because this number, okay, represent the power. Because the power of 10 indicates how many places to move the decimal point left or right back to the original position of the decimal point. Okay. Finally, we write the number using the number of places moved for the power 10. So we can keep in mind that back to the original position of decimal point, with each place to the right, or each digit moved to the right, the exponent goes up, so positively. Conversely, with each place to the left, the exponent goes down negatively. So normally we should, for example, we have a very big number and we want to write it in scientific notation. So it is very meaningful here. It's very useful to use scientific notation because we usually use scientific notation to represent very big numbers and very small numbers. So normally if we have a big number, so we have a number with a lot of zeros to the right without decimal point. So in the first step, so we move the decimal point, but we don't have actually a decimal point in this case. So normally we can always, for any integer, any whole number, to add a decimal point with a zero. Okay? So normally we want to move this decimal point, okay, to have it between the first significant figure and the second one. So normally we move it, all these, to put it here. So 2.3 and 2.3 is a number between 1. It is a real number between 1 and 10. So normally back to the original, back to this, to the original with 0.0. Back to the original, we move to the right, 1 plus 3 places, 4 plus 3, 7 places, and 10 places to the right. Normally, if we move to the right, the exponent goes up. And this number of places show us and represent the power positively, plus 10, 10 power or exponent 10. In the second example, we have a very small number, decimal number with a decimal point. So we want to move this decimal to put it between the first significant figure and the second one, 5.2. It is a number between 0 and 1. Okay, So back from this one to the original decimal point. So we want to move 2 and 3 and 5. So 5 places. 5 places to the left. So -5. The power is -5. So normally, if we write the scientific notation of this number is 5.2 times 10 exponent -5. Moving on to the following exercise or example, write the following as ordinary numbers. So normally, when we multiply by the power of 10, when we have a power, positive power, so we move the decimal point. So we want to enlarge this number to move to a greater one. So normally we move the decimal point to the right 7 places. So normally we have a 9.8. For the first one, we obtain 98. Okay, it remains 6 powers, so 6 zeros to the right. And when we have the exponent negative, so we wanted to minimize or to go further for a smaller number. So normally to the smaller number, we move the decimal point to the left. Okay, we want to move it 9 places, 9 places. So the exponent, as we said before, represents the number of places to move. So we move it to the left 9 places to the left because we have the exponent minus negative exponent. So the first one we obtain 0.337. So normally we have a 0.37. It remains 8 zeros. So we have a 3 and 3 and 6. So 2 zeros, and we put the final decimal point to obtain this number. So normally, and this exercise, it is the reverse technique of the first one. In the second exercise, we have to move from a scientific notation of a given number to the ordinary number. Okay. They ask us why 4 pi 10 power 5 is different from 4 power 5, because easily you can remark that the exponent 5 or the power 5 here is for the 10. So normally we have a 4 by 10 or 100,000, so 400,000 for the first number, or the second one is the 4 multiplied by itself 5 times. So it is a 4, it is a 5 factors of 4. So we will obtain using the calculator 1024. Moving on to the next exercise, they ask us to use the calculator. So it is easy to use the calculator. You can train yourself how to use the calculator with exponent. We have the appropriate buttons clearly on our calculator. So we put 3.4 times 10 power 4. We don't have here any priority because we have a multiplication and multiplication and multiplication. So we don't have a priority between these operations. So 10 power 4. So we put 10 hat 4. Okay, we have a hat like here, like this button on our calculator. Times 4.8 times 10 hat 9 to obtain. Finally, the calculator gives us the result in scientific notation. Radical 2.25 times 10 power 16 give us 15 times 10 power 7. If we want to write it, it is not given in scientific notation because the 15 is the A, and A should be between 1 and 10. Here we have the A 15 bigger than 10. So we can write it in scientific notation 1.5. And moving back, we move 1 place to the right. So 1.5 times 10 power 1 and 10 power 1, as we said before. If we want to combine these two powers of 10, so we have 10 power 1 times 10 power 7. We have the same basis, and the base is 10. So we only add the powers or the exponent to obtain 1.5 times 10 power 8. Finally, if we want to put any set of numbers or to rearrange any set of numbers in descending order or ascending order. We mean by ascending order from smallest to largest, and descending order the reverse or vice versa. So normally we can put all these numbers we put or we change the statement of each number to put them into comparison. What we mean? So no, what we mean by that, normally we can put or we can rewrite all the ordinary numbers that we have, for example, in scientific notation. So normally here we have all these numbers in scientific notation because we have the product of A by power of 10 and A between 0 and by 1 and 10. 4.6 and similarly for the second, similarly for the third, and the fourth is also written in scientific notation. So how to compare these numbers or how to rearrange these numbers in ascending order from smallest to largest? It is very easy to compare only the exponents. Okay, so the exponent, the smallest power of 10 is the smallest number. So minus 16 is the smallest. So 7.7 times 10 minus 16 is the smallest. Then comes 3.1 times 10 minus 12. The following one is 13. 13 is smallest than 15. So normally the 4.6 times 10 power 13. And finally, the biggest, the largest number here is the 3.8 times 10 power 15. When we compare the A's that we have, we compare the A's, the numbers between 1 and 10, when we have the same power of 10. So for example, if we have a 13 here and 13 here, so normally 4.6 is biggest, is greater than 3.8. So normally this is the largest, this is the smallest. These are the idea of scientific notation. Thank you for listening, and bye-bye.